Hello everybody. So this is your second trig video uh, on just trig examples, okay? So quick summary for you. I'm hoping that you watched the last video. I know I said in that previous video that these two are going to be together. I decided to split them up just to make the watching a little bit easier for you so you didn't have to watch like, a 45-minute long video. That's crazy. So just as a quick summary for you and a quick reminder for you, the goal of using trig is to help us or give us a relationship between the sides in a right triangle and the angles in a right triangle, okay? There are three trig functions that we are going to use in this course. You'll learn more as you go through and learn more math, okay, in higher level courses. But the three trig functions that we are going to look at are sine, which is the opposite leg of the angle that you're looking at over the hypotenuse of the triangle, cosine, which is the adjacent leg to the angle that you're concerned about over the hypotenuse, and tangent, which is the opposite leg of the angle you're looking at divided by the adjacent leg of the angle that you're looking at, okay? So that's regular trig, right? And you use regular trig when you want to find a side, okay? If the goal is to find a missing side length, okay? That's when you use regular trig. Okay. And then inverse trig is very, very similar, right? It's the exact same fractions, right? Sine is still opposite over hypotenuse, cosine is still adjacent over hypotenuse, and tangent is still opposite over adjacent. But, okay, we put the fraction inside the parentheses instead of the angle, right? And you use inverse trig when your goal is to find an angle. Okay, that's when you use inverse trig. Okay, all right, so let's jump in to the actual examples here. Okay, so at the very top of this page here, I have the typical formulas that you'll use, right? Just an example for you to remind you how to use these trig functions, okay? And then a key thing that you're going to want to have, right, or keep in mind is our, maybe this is going to cooperate with me. Here we go, is our acronym, SOHCAHTOA. Okay, because that's going to help us pick out which trig functions to use for each problem. Okay, so let's look at this first type of question, which is just writing trig ratios. So I'm given this triangle here. I don't know what the two missing angles are, A and C, but my goal is just to write the fractions, right? The trig fractions in simplest form, right? So I'm looking for sine of A, cosine of A, and tangent of A, right? So A is the angle that I'm concerned about. So I need to label my triangle based on this angle, okay? If you recall in the last video, typically I tell people to label the opposite side first, okay? So if you're not exactly sure where that is, or it's difficult for you to visualize, what I tell people to do is on the angle that they circled, draw an arrow straight through the middle of the triangle. And then the side that you hit is your opposite side. Put a big O right there, okay? Next, I tell people to label the hypotenuse, which is always the longest side across from the right angle. So in this case, that's 17 right here. So I'm going to put an H right there. And then the only side left is your adjacent side. So I'm going to put an A right there. All right. So what that means is sine of angle A is the number for the opposite side, which is 15, divided by the number for the hypotenuse, which is 17. And that fraction is already in simplest form. So that's it. That's all you have to do in this problem. Okay, so let's look at cosine and tangent. So cosine of A, remember, if we look at our acronym, is A over H. So the number associated with the adjacent side is 8. And again, the hypotenuse is 17. Okay? And then tangent is opposite over adjacent. So 15 divided by 8. Okay? Now, these fractions would be different if we were looking at a different angle, right? So just for kicks, right, we're going to pretend that the question was asking you about this angle, angle C, instead. Well, if it is, the hypotenuse is going to be in the same spot, right? Because the hypotenuse is the hypotenuse, okay? But the opposite and adjacent sides will switch, right? Because the side that's opposite angle C is this side. And the side that is adjacent angle C is the 15, right? So what's going to end up happening is if we wrote sine of C, for example, right, that would still opposite over hypotenuse, but now the opposite side is 8. And the hypotenuse is still 17, okay? And if we do cosine, the adjacent side for angle C is 15. And the hypotenuse is still 17. So see how these end up switching, right? That will, that's kind of a rule that will always happen when you switch angles. So, and then for tangent, you're going to have a similar thing that happens, right? So the opposite side now for angle C is 8, and the adjacent side is 15. So for tangent, the fraction flips, okay? So the point and the reason that I did the extra little bit over here in orange is to show you that it's really important that you make sure you're looking at the correct angle, because if you don't, then you're going to label your triangle incorrectly and you could get the question wrong even if you do the trig part correctly, right? Opposite and adjacent are totally dependent upon which side is opposite the angle that you are concerned with, right? And which side is adjacent, right? Those things will change depending on the angle that you circle, okay? But the hypotenuse is always going to stay in the same spot, okay? All right, so let's look at a couple of regular trig examples here, okay? So here we go, right? So we're going to follow our steps for solving trig problems, okay? First step, circle the angle that you want to use. Typically, you should circle the angle that they give you because that makes your life easier, okay? So that's step 1. Step 2, label the triangle based on the information that's given to you and the angle that you chose. So my opposite side is with the x, my hypotenuse is the 17, and the adjacent side is the only one I have left, okay? Step 3, I need to pick a trig function based on the info that I have or where they gave me information. So I have nothing for A, right? There's no variable, there's no side length, there's nothing, right? So instead, I'm going to use O and H. And if I'm using O and H, that is sine. Right? Sine is O and H, okay? Next step, I'm going to write my trig function, right? Write my formula. So I chose sine, so sine of, the angle goes inside the parentheses, 59, equals, and it equals my fraction, x, which is the opposite side, divided by 17, the hypotenuse. All right, and then once you get to this point, you just have to plug a couple of things into your calculator and do some simple algebra. Okay, so remember that this here is just a number. Okay, and it's a number that you get from your calculator. So in my calculator, I'm going to figure out what sine of 59 is. And that value is 0.857. Okay, And then I'm going to bring down the rest of my equation. X over 17. Okay. All right. Now, in order to get x by itself, I need to multiply both sides by 17. So times 17. So I'm going to take that decimal value and multiply it by 17. And when I do, I got 14.57. I'm going to round to 3 decimal places and say 572. So that equals your x value. Now, one thing that I want to note for you is that if you clear the really long decimal in your calculator and just multiply the rounded decimal that you used, you may get really, really close to this number that I got here, but not exactly. That's okay, right? With most trig problems, there's like a margin of error depending on where you round from, right? So as long as you were like pretty close, right, to the point where I could tell that you did set up your problem correctly, then you would get all the points on those types of problems. Okay. All right. So I'm going to do one other one for you, and then I'm going to have you try the third. So I'm actually going to do this one, the one on the right-hand side. Okay. Let me change my color up a little bit. Okay. So let's go through the steps. Step 1, circle the angle. In this one, I'm going to use the angle that they gave me. Step 2, label the triangle. So my opposite side is over here. My hypotenuse is the longest side across from the right angle, so right here. And then my adjacent side is the only one I have left. Okay. Step 3, choose your trig function. Okay. So if I look, hold on. If I look at the information available to me, I have something, either a variable or a number, for A and for O. So I'm not going to use H at all. I'm going to use O and A. So O and A in my acronym is tangent. So that's the trig function I'm going to use. So then I'm going to write my equation. Tangent of, the angle goes inside the parentheses, so 40, equals opposite, 32, over adjacent, x. Okay. So let's go through and solve this. Right? So in my calculator, I need to figure out what tangent of 40 is. Okay, and when I do, I got that tangent of 40 is 0.839. Okay, so 0.839 equals 32 over x. Now, you may be looking at this and being like, but wait, the x is in the denominator. How do I solve this equation? Okay, there's a couple of ways that you can do this, but I'm going to show you the easiest way. Okay, at least in my opinion, this is the easiest way, right? Normally, when you would solve a problem like this, you would take the x and you would move it over to this side, right? Because we want to get rid of the fraction. But then you'd have to then divide by this number, the 0.839. Okay, so here's a little shortcut for you, a fast little trick. Okay, whenever you have an equation that looks like this, where you have some number equals another number divided by a variable, what you can do is take the variable and whatever this number is on the other side of the equal sign and switch them. Okay, it's basically doing the moving the x over and then dividing, but just in one step. Okay, so now I know that x is equal to 32 divided by 0.839. So I'm going to do that in my calculator. Okay, and when I do, I get that x is 38.136. I usually round to 3 decimal places, but you could round to 2 decimal places. That would be okay. All right, y'all. So what I would love for you to do is pause the video and give this middle one right here a try. So give that middle one a try, and then check back with me in just a sec to see how you did. All right, folks, so I've worked out that middle problem. Check your answer against mine. So not surprisingly, since we did a sine and a tangent problem, this is a cosine problem, right? But we want to make sure that we verify it, right? So I circled the angle, labeled opposite, hypotenuse, adjacent, right? And I realized I had nothing for O. It's not going to help me, but I do have something, either a variable or a number, for A and H, right? A and H goes with cosine, so I'm going to use cosine, right? Then I set up my equation. So cosine of the angle equals x over 20, okay? Adjacent over hypotenuse. Right? I plugged cosine of 27 into my calculator and got this decimal value, 0.891. And then in order to get x by itself, I multiplied by 20 on both sides to cancel the 20 out. And when I did and plugged that again into my calculator, I got that x was equal to 17.82. Right? 8205 rounded. Okay. All right. So that is regular trig. Most of the problems that you do will be with regular trig because it helps you find missing sides when you don't have a lot of information in a triangle, right? Once you have, say, two sides, you can use other tools that you know, like the Pythagorean theorem, in order to find anything else that's missing, right? Which is kind of neat, okay? So give me a second to clear my screen off, and then we're going to look at inverse trig next. All right, folks, so here we go. Here is inverse trig, okay? So even though we're using inverse trig, you're still going to follow the exact same steps. Okay, it's just the function that you write at the end will be a little bit different. And typically with these, you don't have to solve for anything. As soon as you set up the function, the variable will already be by itself, right? So that way, like, you don't have to do any extra multiplication or anything. The calculator is going to do most of the work for you, which is kind of awesome, okay? So I'm going to do the first two here, and then I'll let you try the third one, okay? So first step is always to circle the angle that I want, right? Well, the angle that I want is the one with the variable in it, okay? And I'm still going to label my triangle with opposite, adjacent, and hypotenuse, okay? So my opposite side is this 12, the hypotenuse is 16, and the adjacent side is this one where I don't have any information, okay? One quick thing before I go on that I probably should have mentioned at the start, okay? A good clue that you're looking for inverse trig is if the variable is the angle inside the triangle, okay? That's a good, like, clue for you that you would want to use inverse trig here and not regular trig. Okay. All right. So I'm still going to pick my trig function based on the info that I have, right? And well, I have nothing for A. There's no variable, no number. So I'm going to use sine because it's opposite and hypotenuse, right? So as a reminder, your acronym is here to remember which trig function to use, okay? So now I need to write my trig function. So this is where it gets a little bit different, right? You're going to write a slightly different function. So normally, as you recall, okay, when you're doing regular trig, you write the trig function and you put the angle inside the parentheses and then it equals the fraction. Since we're doing inverse trig, we're going to switch the fraction and the angle. Put the fraction inside the parentheses, and it will spit out the angle, right? When you plug stuff into the calculator, it will give you an angle measurement, okay? So that's exactly the way that we're going to write this, okay? So this is sine, so I'm still going to write sine, but since it's inverse, I'm going to put a little -1 up here, okay? And then instead of writing the angle in here, inside the parentheses, I'm going to put the fraction, O over H, so 12 over 16. And that equals the angle, X, okay? And just as a reminder, this is just a number that you get by plugging information into your calculator, okay? So I'm going to show you quickly on my calculator. Let me turn my webcam on here. It always shows up in that bottom right corner. Okay, so on my calculator, right, again, if you have it like this, you're going to have a problem because you can't, like, the trig functions aren't there, right? So you have to turn it on its side. Okay, now I'm trying to get this as close to the camera as I can without the glare showing up, but your sine, cosine, and tangent bottoms, or buttons, sorry, you can see, at least in my calculator, are at the bottom, right, down here, okay? But what we want is the inverse trig, not the, like, the inverse trig functions, not the regular trig functions. The ones that you see there are the regular trig functions, okay? So in order to access the, oh my God, sorry. In order to access the inverse trig functions, there's a little button that you have to press, okay? Which is in the top left corner of, at least of my calculator, it's in the top left corner. So that button right underneath the parentheses that says second, the 2 with the ND, okay? So I'm going to click that, and as soon as I do, I'm hoping you can see how now the trig functions at the bottom have the little -1 next to them. Okay, so that's how you access your inverse trig functions. On your calculator, it may look a little different, but usually you're looking for a button that's called second. So I'm going to write it on the screen here. You're usually looking for a button like this, second, or you may be looking for a button that looks like this, INV, which means inverse. Okay, so those would be your buttons on your calculator that you're looking for. If you're using like a fancy TI calculator, like if you have a fancy graphing calculator at home, it'll be a second button usually on the fancy calculators. Okay. All right. So, oops, hold on. So I'm going to actually do this and plug this into my calculator. So on my calculator, I have to type the fraction first and then click the trig button. So if you're using an iPhone, like an iPhone calculator like I am, you'll have to do it in that order. If you're using like an Android calculator, you can just do the buttons in the correct order. Like you can do the sign button first and then type the fraction and it'll spit the answer out at you. Okay, so I'm going to click my button, and when I do, this is what I get. So that is my Engel measurement right there. Okay, 48.59. So that's how many degrees that angle is. Now, if you did this on your calculator and you did not get this number, like you got another really weird number, maybe that has like, it's like really, really small, like it's like 1 something, right? Or maybe it even is just like a decimal value, okay? Then that means your calculator is in the wrong mode. So I'm trying to get this as close to the camera so you guys can kind of see this. So in the bottom left corner of my fanciful calculator, see that button that says RAD, okay? You want that to show, okay? If I click that button, so if you're looking at your calculator and it says DEG, at least for me, that's not correct, right? So we want this to be in degree mode. So you want that button to say RAD, and you don't want to see anything else up at the top. So if I click that RAD button, right, see how the word RAD shows up in the top left corner there? You don't want that there, okay? So that's the way, at least on these kinds of calculators, to put your calculator in the right mode. Most of you will already be in that mode, like that's the default mode, okay? But just in case your calculator spit out a really weird number at you, it's probably not you, it's probably because the calculator is in the wrong mode, okay? All right, so I'm going to turn my webcam off here so that way I can do a little bit more writing, okay? But so like I said, we got 48, whoops, 1 second, hold on. So we got that x is equal to 48.59, and that's degrees. So I'm going to put a little degree symbol right there. And that's it. That's the whole problem, all right? Okay, so I am going to work these other two out. I would love for you to do the same, okay? So pause the video, try these other two inverse trig problems, and then check back with me to see what you got. All right, folks, so those are the other two problems, okay? So the second one was a cosine problem because I had nothing for the opposite value. I had a number for A and a number for H, so that's cosine. When I plug that into my calculator, I got 25.84 degrees. And then the third one, unsurprisingly, is the only one that we haven't looked at yet, which is tangent. So when I circled my angle, labeled my triangle, I saw that there was nothing for H, no variable, no number, nothing, right? So I'm going to eliminate that one, that side I'm not going to use, and I just have information for the opposite and adjacent side, so that means I'm using tangent, okay? So I have tangent with the little inverse, and then the fraction goes inside the parentheses, 30 over 18. Plug that into your calculator, and when you do, you get 59.04 degrees. All right, you guys. So I've got the last few examples for you are all real-world trig problems. So trigonometry is actually something that people use all the time in the real world in order to make sure that they're creating shapes that are the right size, that their angles are correct, making sure that things are not too steep in order to figure out how far planes are, for example, away from a shore. Like there's lots of different things used in navigation. It's used in like looking for stars, like star charting. It's used in lots of different ways. Okay, so I'm going to pause the video real quick and clear off my screen. And then we're going to do a couple of real world trig problems. All right, folks, so these are your last couple of examples, and these are real world trig problems. Now, the only difference between real world trig problems, meaning like word problems, and the problems that we've done previously in this video is that you have a description of a scenario rather than a picture, okay? So genuinely, all you really have to do here, the only other extra thing you have to do is draw the picture and then take the information from the description of the scenario, from the word problem, and label the triangle. As soon as you do that, you will have problems that are exactly like the ones that we've done throughout this video, okay? So let's take a look. I'm actually going to do this one over here on the right, the rightmost problem, and then I'm going to give you all a chance to try these other two. Okay, so let's take a look at what's going on here. Okay, so this says the angle of depression from the top of a flagpole to a point 20 feet from its base measures 52 degrees. Find the height of the flagpole and round to the nearest tenth. Okay, so I'm going to first draw a right triangle. Okay, the drawing does not have to be beautiful. Okay, you just want it to be a representation of what the problem is talking about. So this says we're talking about the top of a flagpole. So here's my little flag, right? This is my flagpole. Okay. Okay, so, and then next thing I'm going to do here is I'm going to pull out the important information. Actually, one moment, please. I'm going to pull out the important information from the word problem, right? So they're saying the angle of depression, okay, which if you don't know what that is, the angle of depression is when you have a slanted line like this and you draw another horizontal line here. The angle of depression is the angle from this dotted line down to your slanted line, okay? So they said that angle, the angle of depression from the top of a flagpole to a point 20 feet from its base measures 52 degrees. Okay, so this angle here is 52 degrees. Now, if you recall, when we did parallel lines cut by a transversal, we would have those angle relationships, okay? So the angle up here, the angle of depression, is the same as the angle here, okay? Which typically we call the angle of elevation, okay? So there's my angle, okay? The other thing that it said, the other number that we have in the problem is that the flagpole from the flagpole, we want to go 20 feet from its base. So if this here is my flagpole, I want to go 20 feet away from its base to find where the angle is. So that means this value here is 20 feet, okay? All right, so then I need to look and ask myself, okay, what do they actually want me to find? And what they actually want me to find is the height of the flagpole. So I don't care about this slanted distance. I care about this, the height of the flagpole, okay? Now, if you kind of ignore my dotted dashed line up here with the angle of depression and look just at the triangle, this looks very similar to the problems that we've been doing up to this point, right? So let's follow our steps, right? So remember, step 1, circle the angle, which is this angle here. Label the triangle with opposite, adjacent, and hypotenuse. So here's my opposite side. My hypotenuse is my slanted side, the longest side here. And then the adjacent side is the only one I have left. So I'm going to look at my information and say, well, there's nothing attached to the hypotenuse, right? I don't know what that length is. Okay, this 52 is not attached to the hypotenuse. It's the angle down here. Okay, so that means I have O and A, which means I'm going to use tangent. So I have tangent, and this is regular trig, okay, because I'm looking for a side. So this is not inverse trig. I'm going to do regular trig, okay, because they gave me a number for the angle. So I have tangent of the angle goes inside the parentheses equals opposite, which is x, over adjacent, which is 20. Okay, so I'm going to go to my handy dandy calculator and figure out what tangent of 52 is. Okay, tangent of 52 is 1.28 if you round. Okay, and that equals x over 20. To figure out what x is, I'm going to multiply by 20 on both sides. And when I do, I get 25.6 if you round, okay? And then the only thing that I'm missing is units. So because they gave me units in the problem, I need to put units in my answer. So that flagpole is about 25.6 feet tall, all right? And that's it, right? So the hard part about this, or the different part about this, is just drawing the picture, drawing and labeling the picture. But once you have that, okay, once you have that information, the rest of the problem is exactly the same as the other types of problems that you've done, right? And you follow the exact same steps, all right? So what I'm going to have you guys do here is try these other two. I will let you know one of them is a regular trig problem, and one of them is an inverse trig problem. So make sure you label your triangles correctly, okay? And then you probably are picking up on a pattern, right? That most of the examples in this first column end up being sine. The ones in the second column end up being cosine. So it's a little hint for you if you're going through and solving these, right? So try these out and then check back with me in a second. We'll see how you did. All right, everybody, so let's take a look at these last two problems here, okay? So looking at the one on the left, okay, this problem said we have a piece of wire is attached from the top of a utility pole down to a stake in the ground, okay? So that's the slanted part, right? It says if the angle of elevation from the stake to the top of the pole is 39 degrees, find the length of the wire. Okay, so I have my right triangle. Okay, the angle of elevation is down in the bottom right corner of my drawing, between the stake and the pole. Okay, uh, the pole is that vertical line, it's 45 feet, and then we're trying to find the length of the wire, which is labeled in purple there, it's X, right? So I circled my angle, labeled my triangle, realized that I have information at O and H, right? So that means I'm dealing with sine. And I know I'm doing a regular trig problem because I'm looking for a side length, okay? So then I set up my equation, sine of 39 equals 45 over x, right? I plugged sine of 39 into my calculator and got 0.629 equals 45 over x. Now remember, the shortcut here is to take your variable and the decimal value and switch them, right? It's basically just combining two math steps into one, okay? So I got that x is 45 over that decimal, which is 71.5, and then I made sure to include feet, right? Because that's the units in the problem, so I need to make sure I give units in my answer, okay? All right, and then that middle one there says we have a 9-foot ladder that's resting against the side of a wall, right? So that's the hypotenuse, right? The wall is the vertical part, right? The hypotenuse is the ladder, which I've very skillfully, sarcasm, drawn on the screen for you there, okay? So then it says the bottom of the ladder is 2 feet from the base of the wall. So the bottom of the ladder and the base of the wall, that distance makes up the horizontal part of the triangle, so 2 feet. And they want to know the measure of the angle between the ladder and the ground. So I've labeled that in orange for you as x, okay? So I know, looking at what I have available to me, this is going to be an inverse problem, an inverse trig problem. And I know that because I'm looking for an angle measurement, okay? So again, I circled my angle, labeled my triangle, realized that I had numbers at A and H, so that's cosine. So my equation was cosine inverse, that's what the little -1 is for, parentheses, and then remember, for inverse, you put the fraction inside the parentheses. So the fraction is A over H, so 2 over 9 equals your angle, which is x. And then all I did was do cosine -1 of 2 over 9 in my calculator, and I got 77.16 degrees. The question says round to the nearest tenth, so if you round it, it's 77.2 degrees. All right, you guys. So I know that this video was a little bit long, but I'm hoping that this was helpful for you in getting a lot of examples and a lot of practice with how to do trig problems, all the way from your basic just identifying ratios up through these more difficult ones where you have to figure out what type of trig you're using in a word problem. Right? If you're still feeling like you need more examples, I do have one more video for you that's just practice problems, where you can try some more examples with me if you want to do that. All right. So with that, I'm going to go ahead and end this video here, and I will see you guys in the next one. Bye, everybody.